everyone. Today I'm going to show you, we're doing two videos, two parts, the same technique, and it's called elimination. So in this section on solving systems, we've looked at, first of all, graphing, the easiest way to find where two lines cross, or let's say the most straightforward way. The easiest ways to avoid graphing, actually, we learned two algebraic techniques. You've seen substitution. This is the second one, elimination. I'm going to show it in two parts. So you should see all different varieties of what you may be looking at, and you'll have the tools to solve in either situation. So I'm starting off here with, I got two equations. I hope I have a good enough marker. So if I look at these two equations, I'm going to start off with solving it by substitution. Let's see what answer we get. X plus y equals 10, x minus y equals 4. I'm going to number them. I'll call this equation 1 and this equation 2. And I'll say from, let's do it from 2 just to be different. I'm going to isolate either x or y. Let's do x. So I'll say, it says this, I'll throw y over to the other side, and then I've got y plus 4. So now I have this expression for x that I'm going to replace for x in the first equation. It came from the second equation, I'll replace it in the first. Okay, so sub for x in 1, in equation 1. So now instead of x plus y, I'm going to have, this is x plus y equals 10. I'll replace x with y plus 4. So I have y plus 4 plus y equals 10. So, gathering like terms, I have two y's and the 4 I'm going to put on the other side. Crosses over, changes sign, right? So I got 2y is going to equal 6. Which means, dividing both sides by 2, y equals 3. Okay, so I got y equals 3. I'll substitute that into this expression, this altered version of equation 2, and I will have the x coordinate of the point of intersection is going to be 3 plus 4, which is 7. And now we have the solution. So the solution is x equals 7, y equals 3. Okay. Substitution, fabulous technique, and it's something you'll be using a lot in your years of studying math. So I'm going to erase this, and I'm going to keep that because I'm going to get the same answer using elimination. Oh, I'm so happy for the video age. Okay. Elimination, what you're doing is you're going to either add or subtract the two equations together, term by term. And what you want to do is eliminate one of the two variables, either x or y, in doing so. So, if I look at this equation, you notice that here, the two x terms in each equation, they have the same coefficient. The two y terms, they have almost the same coefficient. Numerically, it's the same, but the signs are different. So watch what happens. I'm going to add these together. And watch what happens. See, I've aligned it up so the x's are above the x's, the y's are above the y's, the numbers are above the numbers. So what I gotta do is just add them up according to their own type. X plus x gives me 2x. Y minus y gives me 0y. They cancel each other out. 10 plus negative 4 will give me 6. So by making 0y, 0 is the coefficient, I have eliminated y. And I have an equation that's only in x. It's only in one variable, hence it can be solved. 2x equals 6. Divide both sides by 2. Alright. X equals 3. Just like we have over there. This marker is dying on me. Okay? X equals 3. And then you want to find y, substitute back into either equation. Doesn't matter. So let's use equation 1. Oh, this is much better, this marker. Okay. In 1 says, equation 1 says x plus y equals 10. I'll substitute 3 in here. This means 3 plus y equals 10. So y equals 10 minus 3, 7. Same answer. Okay? So I added them. I added them because I noticed I have a plus y and a minus y. If I add these two together, those are going to cancel each other out. What if I subtracted? I can do that. These are exactly the same, the coefficients of x. They're both positive 1. So, I could have done it by subtraction. I could have said 1 minus 2. Equation 1 minus equation 2. Then I have x minus x, 0x. Now careful, this is y minus negative y. Yes, equals 10 minus negative 4. Okay, dude? Have a good shift. This is my son's going to work. Okay, so 0x, x is gone. And now I have, this is y plus y. 10 minus negative 4 gives you 10 plus 4, which is 14. 2y equals 14. So y equals 7. Okay, so instead of doing it a different way, and why do I got y equals 7? Did I screw this up? Oh gosh, I'm so sorry. I messed this up. Oh, my brain is ridiculous. Naturally, you know the difference between where x and y is supposed to be replaced in the coordinates, the bracketed coordinates. Okay, that's it. Y equals 7. And then I would find x by substituting back y equals 7 back into this equation. Again. So let me try, let's do a whole new system by elimination. Okay, I have a nice one here I wrote down because we want to know, they don't always look like that. What if we had x minus y equals 7, and I have 2x plus y equals 20. Okay. I'm doing it both ways, even though you only have to do one. Okay? So again, I've got it stacked up. X's, Y's, numbers. Well, you always take a look at the coefficients you have to see what's going to be the easiest. You want the easiest, the fastest way? Laziness. Okay. These Y's, they're it's perfect. Look, if I had negative Y and positive Y, Y is gone. That's what I want. So let me add them. I'll say equation 1 plus equation 2. Okay? X and 2x is 3x. Negative Y plus Y is nothing. Let's leave it out. 7 and 20 is 27. Okay? This means 3x equals 27. Divide both sides by 3. And you get x is 27 divided by 3. It's 9. I got x equals 9. Okay, and then finding y is easy. I just substitute into either 1 or 2. I'll substitute in 2 just to be different. Sub x equals 9 in 2. What do I got? I have 2 times 9 instead of 2 times x plus y equals 20. 18 plus y equals 20. Throw the 18 over the other side. Y equals 20 minus 18, which is 2. So what's the solution here? X equals 9, y equals 2. That's where these two lines meet. X equals 9, y equals 2. Okay? Say I did it the other way. Now here's where we're going to partially move into elimination 2. I'll finish this off because some of you may have a huh moment. No worries. What I can do is I can say, no, I want to eliminate the x's, not the y's. That's fine. It has a different coefficient. But what I can do is, to make the coefficients the same, I will multiply this entire equation by 2. 2 times 1. Equation 1. Okay? And that's fine. As long as you do the same thing to both sides, it's cool. So I'm going to say 2 times this side. 2 times the other side. That's fine. Still equality, the same treatment of both sides. Okay, so this gives me 2x minus 2y equals 14. Okay, and I'm going to call this now equation 3, and I'm going to let that replace equation 1. And that's fine, because it's really the same equation. Everything's just been doubled. And then I'll write 2 below it as is. 2x plus y equals 20. And now I'm going to subtract these. Equation 3 minus equation 2. Okay, 2x take away 2x is nothing. Minus 2y take away y gives me minus 3y. 14 take away 20 is negative 6. Okay, and then I have negative 3y equals negative 6. Divide both sides by negative 3. What do I got? Y equals 2. Same thing. Y equals 2. Then I want to find x. Alright. I'll sub y equals 2 into either one of these two. They'll both give me the same answer. Let's try it in 1. Sub y equals 2 in 1. I have x minus 2 equals 7. X equals, putting the 2 on the other side, becomes a positive 2. None. Y equals 2, x equals 9. Same thing. Elimination part 2. I'm going to do two things. I'm going to do another one where we may have to multiply both sides of the equation. Sometimes they're all different, and you have to multiply both equations times something. Sometimes they're not always arranged so that the x's are aligned and the y's are aligned and the equal sign is aligned, and so that just involves a little moving around, which is fine. It's all good. It's all good. Okay, so here endeth part 1. Next, I'll see you in part 2.